Today we will discuss some more problems based on the rotation of the complex numbers which are asked in the competitive examinations in the previous years. Example 1. ABCD is a rhombus such that its diagonals AC and BD intersect at the point M and satisfy BD is equal to twice of AC. And if the point D and M represent the complex number 1 plus I and 2 minus I respectively, then the point A represent the complex number 3 minus 1 by 2I, B is 3 plus 1 by 2I, C is 1 plus 3 by 2I, and D is 1 minus 3 by 2I. Now let us come to the solution. AC and BD intersect at M and BD is equal to twice of AC. The M is represented by 2 minus I and D is represented by 1 plus I. Now we have to find out the point A, which can be at this place or at this place. That means you have to rotate a complex vector MD in the direction of AM. That is, final position will be AM and initial position will be DM. Suppose we assume the coordinates of A as x comma y. Now the complex number represented by AM will be x minus x plus iy minus 2 minus I. That is, AM will be x minus 2 plus I times of y plus 1. Similarly, MD will be represented by MD is equal to, that is, 1 plus I minus 2 minus I. That will become MD will be equal to minus 1 plus 2I. Now, final position, that is x minus 2 plus I times of y plus 1 divided by initial position, that is 1 plus 2I, is equal to length of the final position, that is AM divided by MD into e to the power I pi by 2. Because pi by 2 is the angle through which we rotated the MD line in the direction of AM. So, x minus 2 plus I times of y plus 1 divided by minus 1 plus 2I is equal to 1 by 2I. That is, x minus 2 plus I times of y plus 1 is equal to, if you multiply the denominator to 1 by 2 into I, you will get minus 1 by 2I minus 1. If you compare, then x minus 2 is equal to minus 1 and y plus 1 is equal to minus half. So x becomes 1 and y becomes minus 3 by 2. So one of the y can be represented, the vertex A can be represented by 1 comma minus 3 by 2, or if you represent it by the complex number, that will become 1 minus 3 by 2I. Now the position of A can be at the position where the C is. So the rotation, if you rotate the complex number in the clockwise direction, then you will have to take the negative sign. That is, x minus 2 plus I times of y plus 1 divided by minus 1 plus 2I. This will be equal to minus of AM upon MD into e to the power I minus pi by 2. That is, x minus 2 plus I times of y plus 1 upon minus 1 plus 2I is equal to 1 by 2 into minus I. Now the equation becomes x minus 2 plus I times of y plus 1 is equal to 1 by 2I plus 1. That is, x minus 2 is equal to 1 and y plus 1 is equal to 1 by 2. So x becomes 3 and y becomes minus half. So the second new position of point A will be 3 comma minus half, that becomes 3 minus 1 by 2I. This objective type question has two answers, that is first and fourth. A and D are the right answers. Let us come to the example 2, that is, a man walks a distance of 3 units from origin towards the northeast direction. From there, he walks a distance of 4 units towards the northwest direction to reach at a point P. The position of P in the Argand plane is 3 into e to the power I pi by 4 plus 4I. B is 3 minus 4I into e to the power I pi by 4. C is 4 plus 3i into e to the power I pi by 4, and d is 3 plus 4i into e to the power I pi by 4. Let us come to the solution. A man walks a distance of 3 units from origin towards the northeast direction. So OB will be root of OA square plus AB square. That is, OB will be root of 3 square plus 4 square. That is root of 25. That becomes 5. Now the OA complex vector is inclined at an angle of 45 degree with the positive direction of x-axis. So A can be represented by OA will be 3 into e to the power I pi by 4. That becomes 3 into cos pi by 4 plus I sin pi by 4. Now if we rotate OA in the direction of OB and let xy be the coordinates of B, then x plus iy divided by 3 into e to the power I pi by 4 is equal to length OB divided by OA into e to the power I theta. Theta is the angle between OA and OB. Now x plus iy divided by 3 into e to the power I pi by 4 is equal to 5 by 3 into e to the power I theta can be written as cos theta plus I sin theta. Now cos theta will be 3 by 5 and sin theta will be 4 by 5. So x plus iy divided by 3 into e to the power I pi by 4 is equal to 5 by 3 into 3 by 5 plus I times of 4 by 5. Now x plus iy can be written as 3 e to the power I pi by 4 into 5 by 3, 3 plus 4i by 5. 5 cancels from 5, 3 cancels from 3. So x plus iy will be 3 plus 4i into e to the power I pi by 4. So the correct answer is D.